Assalamualaikum and hi everyone. We are from DCC30112 and today we will present a topic of Atterberg limit, which is Casagrande method. Before we start, we would like to thank to our beloved lecturer, Madam Nur Asia, to giving us the opportunity to be here today. Before we start, allow us to introduce ourselves first. Hello and hi everyone, my name is Nur Shabiha binti Hamdan. My matric number is 01DKA20F2017. Today I will explain to you guys about introduction, objective and theory of Atterberg limit. Introduction. The Atterberg limit test is a classification test used to determine the moisture content at which fine-grained clay and silt soils transition between the different phases. The water concentrations that define transitions between solid, plastic, and liquid forms of a soil type are known as Atterberg limits. The tests are only applicable to cohesive soil with a significant silt or soil percentage, and they can be done on sand or silts with a high sand percentage. Detailed mineralogical studies of cohesive soil have revealed that Atterberg limits are strongly linked to clay concentration and clay mineral species, and hence to the climatic and geologic conditions that prevail during deposition and the post-depositional weathering cycle. The objective of this experiment is to determine a liquid limit and plastic limit and to classify the soil sample. Theory. The Atterberg limits can be used to distinguish between silt and clay, and it can distinguish between different types of silts and clays. These limits were created by Albert Atterberg, a Swedish chemist. They were later refined by Arthur Casagrande. These distinctions in soil are used in picking the soil to build structures on top. So when wet, retain water and expand in volume. The amount of expansion is related to the ability of the soil to take in water and its structural makeup, the type of atoms present. These tests are mainly used on clay and silty soils, since these are the soils that expand and shrink due to moisture content. Clays and silts react with the water and thus change sizes and have varying shear strengths. Thus, these tests are used widely in the preliminary stages of building any structure to ensure that the soil will have the correct amount of shear strength and not too much change in volume as it expands and shrinks with different moisture contents. That's all from me. I will pass this presentation to our next member. Thank you.
Thank you, Shabiha. Hi, my name is Ahmad Faizuddin bin Muhammad. My registration number is 01DKA20F1013. So today I will continue this presentation. I will explain about apparatus. Okay, first apparatus is Casagrande apparatus. Second is bowl. Bowl is to prepare a soil sample. And third is water. Water is used to add moisture to the soil sample. And fourth, spatula. Spatula is used to spread soil sample on the glass plate. Next, glass. Glass is used to roll the soil sample on it. And next, weighting scale. We also use hammer, tray, soil, and spoon. Spoon is used to stir the soil and water. That's all from me. Next presentation will continue by Luqman Hakim. Thank you.
Thank you so much to Ahmad Faizuddin for allowing me to continue with this presentation. Hello everyone, My name is Nomanaki Menasulizam. My registration number is 01DK20F2009. So right now I'm going to continue with this presentation about the procedure of this experiment. Let's go. Okay, there we go, the procedure slide. Okay, so the next slide. Okay, for number one, as you guys can see right here, we have to crush the soil that is placed on a tray into small pieces by using hammer. And the next step is we have to sieve the soil, which must pass the sieve test of number 36, 0.425. Okay, for step number 3, after the soil has gone through the sieving process, we have to put the soil into the bowl, like shown in this picture. And for number 4, we have to stir or mix the soil with distilled water, like this one. Okay, so step 5 is mix until the soil and water inherent. As you guys can see right here, the soil and water has become inherent already. It's totally different from the previous picture or the previous step that we have seen just now. Okay, for step number 6, we have to put small amount of soil into the bowl of Casa Grande apparatus. The 7th step is we have to smudge the center of the soil. And the 8th one is stomp until the soil rejoined. We have to actually stomp the soil using this Casa Grande apparatus. For step number 9, we have to take a small amount of the soil sample. As you guys can see right here, based on this picture, this person used it's pretty much you can use any tools as long as you can get that small amount of that soil sample from the bowl of Casa Grande apparatus. And for step number 10, we have to roll the sample into circle and cut off the sample into half. Okay, now we are at the step number 11. For this step, we actually have to roll the sample until the diameter becomes 3 to 4 millimeter thick. Okay, so based on the first diagram on this slide, there are 2 persons rolling the soil sample in order to get that diameter of 3 to 4 millimeter thick. And the second diagram right here, we have a ruler here showing the length of the soil sample. So for this one, I will say it's 4 millimeter because it's pretty much nearly to the 5th scale. Let's move on to the step number 12. We have to put the sample into the container and mark the sample. And next, we have to weigh the soil sample, including the container that we use in order to store the soil sample. And last but not least, the final step is we have to dry the sample in the drying oven for 24 hours. Now that I have finished my presentation part by explaining the Atterberg limit test by using Casa Grande method procedure. So now I'll pass this presentation to Muhammad Hazid to continue with the data. Thank you so much to all of you for willing to lending your ears listening to my presentation, especially to our lecturer, Madam Nur Asya. Thank you so much. Have a good day.
Hello, hi everyone. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazid and my microphone number is 01DK20F2013. And I will continue this presentation with data. First, look at the slide. We have a table that have a limit, liquid limit, FL, and test number. First, container number 1, mass of container is 5.93 and mass of wet soil plus container is 12.52 and mass of dry soil plus container is 10.49 and number of blow is 50. And for test number 2 is 6.30 and 10.38 and 8.95 and number of blow is 45. And for test number 3, 6.08, 15.11, 112.28 and number of blow is 36. And for test number 4 is 6.36, 12.70, 10.50 and number of blow is 18. And plastic limit for test number 1 is 5.974, 6.973, 6.703, and for plastic limit test number 2 is 5.974, 6.9339 and 6.769 and 6.59, and test number 3 is 5.298, 6.592 and 6.439, and for test number 4 is 5.162, 5.442, 5.321. And next is moisture content. Moisture content equal to mass of wet soil plus container subtract minus mass of dry soil plus container divided by mass of dry soil by container minus mass of container multiplied by 100%. So the answer is moist content percent liquid limit is test number 1 44.52, and for test number 2 53.96, and for test number 3 is 45.65, and for test number 4 is 53.14. And next moisture content in plastic limits. Test number 1 is 37.04, test number 2 is 31.64, test number 3 is 13.41, and test number 4 is 76.10. That's all from me. Thank you. And for the last one is conclusion. Based on the calculation, we get a liquid limit is 50%. Next, plastic limit that we get is 39.55%. For the plasticity index is 10.45%. So from the calculation, we can determine the objective of the test. That's all from us. Thank you for listening.